1-7 absolute values. We're going to look at equations and inequalities with absolute values. So in case you don't know what absolute values are, on a number line, if I ask you for the absolute value of a number, I'm asking you how far away from 0 is that number. So let's say I'm giving you the number 4. 1, 2, 3, 4. So here's 4. How far away from 0 is 4? Or another way to ask that question, what is the absolute value of 4? How far away is it? It's 4. And if I ask you, what is the absolute value of -4? How far away from -4 is, how far away is -4 from 0? I'm asking you, what is the absolute value of -4? So the absolute value of -4, or the absolute value of 4, is 4. They are from here to here, 4 units away. All right? So that's what we're talking about. How far away from 0 is it? So here, if I'm solving for x here, I want to know what number has an absolute value of 9. So what number is 9 spaces away from 0? There's 2. There's 9, and there's a -9. So sometimes the way you'll see this, the answer is written like this, plus or minus 9. The absolute there, x can be a +9, or sorry, a +9, or it could be a -9. So if you ever see these symbols, that's what it means. Here, we have to solve for x, but there's a number on this side. So before we get the absolute value, you have to get rid of this number by using inverse operations. So the inverse operation, we add 2 to both sides. We're going to get 8. And now I ask you, what number for x has an absolute value of 8? So what number has an absolute value of 8? +8 and -8. So x equals +8 or -8. That's the absolute value of x. Okay? So let's go a little bit more complicated. Let's go to these. Now we have more than just x inside. Now we have a lot of numbers. So if you're solving for an equation with absolute values, what you have to do first is don't treat them like parentheses. These are not parentheses, okay? You have to get rid of the numbers that are with x. So you have to get rid of this 5, and you have to get rid of this 2. The problem is, because the 5 is inside the absolute values, you can't get rid of the 5 yet. You can't do that. So you have to get rid of the 2. So what is this 2 doing? It's multiplying. So to get rid of it, inverse operations, we divide both sides by 2. Then we have this. X plus 5 equals 2. Now, here's the weird thing. Because we know there's 2 possibilities, we have to solve this 2 different ways, okay? 2 different ways. The first way we're going to solve it is with a regular 2. What if it's a regular 2 inside? The other way we're going to solve it is, what if it was a -2? Because if you think about the answers that we've been talking about, whatever's in here has to have an absolute value of 2, which means this is either a +2 or this is a -2. So you have to solve for both cases. So here, inverse operations, and guess what? The same inverse operation. You're going to do the same step to both sides. In this case, we get a -3, but in this case, we get a -7. So the answer for this is x can be -3, and it can also be -7. Those are your 2 answers. All right. Okay, next. Now this one, we have to get rid of these 2 numbers, but if you notice, these 2 numbers are inside the absolute values. This 2 was outside, so I had to get rid of it. Here, they're inside. So I go straight into my two scenarios. Either the absolute values are 12, either this is 12 or it's a negative 12. So I have to set them equal to both of those numbers to get both answers. Either it's 12 or it's negative 12. Running out of space here. All right, so inverse operations, we're going to add 6 to both sides. And remember, it's the same steps. I'm just kind of doing it all at once. So this one gives me 18, but this one actually gives me negative 6, because negative 12 plus 6 is negative 6. Next, this is multiplying by 3, so we're going to divide by 3. And it's the same inverse operation on both equations. So here I'm going to get x is 6, but here I'm going to get x is negative 2. So your two answers for this one are x equals 6 or x equals negative 2. Both of these numbers, if you plug it in, will give you an absolute value of 12. All right? All right, last. This one. And this is a word problem, so let me pull up the word problem. All right, so on a road trip, Andrew plans to use cruise control for 125 miles, plus or minus 20 miles. Write and solve an equation to find the minimum and the maximum number of hours for Andrew's road trip. So in the book, it actually uses absolute values. I'm not going to do that. Here's why. It wants me to solve for two things, the minimum and the maximum. So that means he's probably not going to actually get to 125. He's going to get close to 125. Well, how close? Plus or minus 20. So what we're doing here is there is one situation where he makes it under 20 miles, but there is another situation where he goes over 20 miles. This is your minimum, this is your maximum. So in the minimum case is 105. The maximum case is 145. So I'm going to set up two equations for this, where one equation is set to this distance and another equation is set to this distance. Oh, right, this is distance. So we're using distance equals rate times time. This is the formula we're using. So I'm going to set up two formulas. 105 equals, what's the rate of speed? Oh, it's right there. It's in the speedometer. 50 miles per hour times t, and the maximum case, 145, same speed, different time. And guys, we solve for both. Now, how are we going to solve for both? We're going to use inverse operations. We're going to divide both numbers by 50. Again, you're going to get two answers, and that's what you kind of expect in these problems, honestly. We expect these problems to give us two answers. My first one, I'm getting, the answer is 2.1. 2.1. And in this one, I'm getting 2.9. Okay, so the question is, how long does it take, right? Find the hours. So this is 2.1 hours and this is 2.9 hours, almost 3 hours. So that's about how long he's going to be on cruise control. All right, next question. Now we're going to get to inequalities. Now, for inequalities with absolute values, it's kind of similar. There's two possibilities, but there's going to be one key difference, okay? In this case, sorry, let me focus this again. It's kind of lost focus. And it still doesn't look that clear. Let me try that one more time. There we go. Looks much better. Sorry about that. Sometimes it loses focus. I don't know why. Okay, now, here, like we said, there's two possibilities. It can be a positive 15 or a negative 15. But in this case, one answer is 15. So the absolute value of x is greater than 15. So 16, 17, 18, 19, 20. But What about the negative version? Well, if you're going to put in the negative answer, you're changing the sign. And guys, if you change the sign in an inequality, you also flip the sign. So those are your two answers. X can be greater than 15 or X can be less than negative 15. And if you think about it, it makes sense because what numbers are less than negative 15? Negative 16, negative 17, negative 18. And if you plug in those numbers in here, absolute values will make them positive. Okay, here, if you plug in numbers greater than 15, 16, 17, 18, 19, they stay positive. So all those numbers work. And the same thing here. The positive number would just be like this for 7, but the negative number would result in flipping the sign like that. Okay, so when you have these, we have to do a number line. So let's draw our number lines for this. And so I'm going to make them a little quicker than usual. So here's 0, there's negative 15, there's positive 15, here's 0, there's negative 7, there's positive 7, okay? So really quick number lines. Okay, so the first answer here, X is greater than 15, so it's an open circle. It's greater than, so it goes to the right, this way. X is less than negative 15, open circle, less than goes left. And I do not know why it's still losing focus. It's really bothering me. Sorry about that, guys. It's not as clear as I want it to be. Okay, here, X is less than 7, so, oh, and equal to. So this circle will be closed, going this way. And this circle is greater than negative 7, also closed, going this way. Oh, but you notice they're going towards each other? Okay, in this case, when they go towards each other, they combined. So you're not going to see arrows. You'll see two circles, and you'll see the numbers in between them. So your answers for this one are the numbers in between, and your answers for this one are the numbers going this way and the numbers going that way. So that is a key difference. Okay, let's solve some inequalities with these. All right, same steps as before. You cannot have numbers outside the absolute values when you're solving it. So the first thing here is to get rid of that negative 6 using inverse operations. We're going to end up with, oh, I forgot the x. Sorry, absolute value of 3x, and I get 15. Now you're going to set it up two ways, okay? You're going to set it up two ways. The first one will be exactly the same for the positive 15, but for the negative 15, because we're changing the sign, we have to flip the inequality. So the inequality flips. Now we solve. We're going to do both of these, we're going to divide. So if we divide both of these, this answer is 5, and this answer is negative 5. Okay, so my number line for this one. This one says x is greater than or equal to, so I shade it in, I go that way. And this one says x is less than or equal to, so shade it in and go that way. And that's the number line for this one. Okay, over here, there's no number outside the absolute values, so we're going to go straight into setting up the two options that we have, where the first option stays exactly the same. We leave it the same. Just get rid of the absolute values. But for the negative option, because we're going to change the sign and make it a negative, we have to flip the inequality. We have to flip it. Okay. Now the steps are going to be the same for solving both of them. Inverse operations. Cancel out to 12. Cancel out to 12. This will give me 4x is less than 32. This will give me 4x is greater than negative 8. All right. And then we're going to divide by 4. So here x is less than 8, and here x is greater than -2. Okay, so those are my two answers. Now, my number line, I put 0 in the middle, put -2 over here, I'll put 8 over here. Okay, sorry, they're not very specific. This one is an open circle going less than. This one is, oh, an open circle going greater than. So I noticed that they're going towards each other. So this usually means it's going to merge. The numbers that I can choose for my answers are in between the -2 and the 8. All right, last question is a word problem. So let me move this up here just so I have some more space to write. So members of a debate team are traveling to a tournament where they will stay in a hotel for 4 nights. The cost of each member must be within $20 of $175. Which of the hotels shown can they consider? So guys, again, what I'm going to say is they use absolute values for this. I'm going to use the idea of the minimum amount and the maximum amount, what we were talking about last time. When they say within $20, what they're saying is 175 is the budget, but you can go below $20 from that, or you can go above $20 from that. So what that really means is your minimum amount, your minimum is going to be 155. That's the least amount you can spend. And the maximum amount you can spend is 195. So if you look at the book, it's going to be different, but I like to do it this way. What's the minimum? What's the maximum? And remember, we're trying to spend in between that amount. So they're staying 4 nights. So 4 nights at the hotel. We're trying to figure out which of these hotels is the best option, A, B, C. Which one falls within the budget? So we have to solve for n. Now guys, when we have a minimum and a maximum, we did this in the last lesson, we divide all sides by 4. And I'm hoping my calculator is working now. Yes. 155 divided by 4, I have one answer. So on the minimum side, the minimum is 38.75. The maximum amount is 48.75. So the budget for your hotel is within 38.75 and 48.75. So which of these hotels is within our budget? Looks like are all of them? A, B, and C? Actually, no, C is above budget, so you can't stay at C. But you can stay at hotel A or B. So you can look at those two prices. So you can stay at this hotel or this hotel, but not C. C would not be recommended. Looking at our budget, we can't go above $48. And guys, that's it.